Hooke's law. Force equals the spring constant times the extension by KayScience.com. Along the x-axis is the force in newtons, and along the y-axis is the extension of the spring in meters. Along the x-axis is the force in newtons. So as you can see here, this graph shows the force applied to an object against its extension. The force is proportional to the extension up to the limit of proportionality. So the limit of proportionality is the maximum force that can be applied before the extension stops being proportional to the force. And for this object, it is 10 newtons. So the maximum force for this object that can be applied before the extension stops being proportional to the force is 10 newtons. So at this part of the graph, the extension is directly proportional to the force. And it's this point here which is the limit of proportionality for this object. So beyond the limit of proportionality, the graph starts to curve, and you'll get a larger extension for each unit increase of force. It's question time. Attempt these questions to check your understanding. So what is Hooke's law? Hooke's law is F equals K times E. The force equals the spring constant times by the extension. So how do we work out K, the spring constant, for this object? So we need to rearrange F equals K times E for K. K equals F divided by E. The spring constant for this object equals the force divided by the extension. So if we applied a 4 Newton force to this object, the object extended by 0.2 meters. So F equals 4 newtons. And the extension is 0.2 meters. So if you do 4 newtons divided by 0.2 meters, you can calculate the spring constant for this object, K. So K equals 20 newtons per meter. And the spring constant is the same, 20 newtons per meter, anywhere along the line that shows that extension is proportional to force. So if we applied a force of 8 newtons, we saw an extension of 0.4 meters. So if you do 8 newtons divided by 0.4 meters, you get K, the spring constant, of 20 newtons per meter. So we recall Hooke's law, F equals K times E. We've got K, the spring constant, 20 newtons per meter, times by 0.3 meters the extension, gives us a force of 6 newtons. So this object has been extended by 0.3 meters, and we see the force that was applied to extend it by 0.3 meters, you get 6 newtons. That's for a spring constant of 20 newtons per meter. It's question time. Attempt these questions to check your understanding. Press pause to practice using those key words. The answers will follow. Press pause to go through your answers and make any corrections to your mistakes. Press pause to answer the questions. The answers will follow. And if you're stuck, just re-watch the video. Press pause to go through your answers and make any corrections to your mistakes.